Hello friends, this is lesson 14.2. Here again we are talking about advanced statistics, and these were the topics what we covered in last lecture. We talked about point estimate, and we said point estimate is estimation of population parameter based on sample or sample size. Then we talked about basic terminologies like confidence interval, confidence level we had, and significance level we had. And now we are going to talk about this third one, testing hypothesis or hypothesis testings, and we will give some examples for them. Now let's see what is hypothesis testing. First we have to know what is hypothesis. Hypothesis is nothing but an assumption that may be true or false. So this is called hypothesis. Testing hypothesis is the procedure whether it is true or false. The hypothesis testing is basically an assumption that we make about the population parameter. So it is a condition, or it is a test, or we can say an assumption that may be true or it may be false. So that is called hypothesis. So now important parameter of hypothesis testing what we have here. First we have to know what is null hypothesis. Null hypothesis is actually the hypothesis which is being tested for possible rejection. For example, any condition what we put, if we think about its rejection, so that is called null hypothesis. It may be true or it may be false, and that is denoted by H naught. So if this null hypothesis is rejected, so what will happen? So we will go and accept another hypothesis which is called the alternative hypothesis. If you are accepting the null hypothesis, then we are rejecting the alternative hypothesis, and this one is denoted by H1. For example, here, does the mean break time of implied differ from 40 minutes? If yes, so it means we are accepting it here. If it is no, then we will be rejecting it, and we will go and accept the second type of hypothesis called alternative hypothesis. And some other things we have to know in testing. What we have, one tail test and we have two tail test. If the data is normally distributed, friends, then we will have two tail test. We will have critical regions or areas on both the sides of normal distributions, and that is called the deviations or standard deviations we call them. The regions, the margins what we have on two sides. But if it is one tailed, so the rejection region will be only on one side. If you remember, we talked about confidence interval. In there I showed you that the rejection or critical areas, if it is on both the sides, so that is called two tail test. If it is only on one side, so it is called one side. And then we have p-value. So p-value is important for rejecting or accepting the hypothesis. Friends, you have to know that. So what is this p-value? P-value is the probability of findings. What we find, the findings, the result, the probability of that is called the p-value, or the result for which we can compare with the level of significance. So that result or findings what we find, the probability of that we compare with level of significance. Here, level of significance, if you remember this level of significance, we said it is generally it is 0.05. It is the value for which we are not sure the value will fall within the interval. So if this p-value is less than that value, level of significance, then what will happen? We will reject the null hypothesis. This you have to remember. If p-value is less than this level of significance, we will reject the null hypothesis. If null hypothesis is rejected, then we will accept the alternative hypothesis. And then something we have here, degree of freedom. So what is this degree of freedom? Degree of freedom is the number of independent values that a statistical analysis can estimate. Or we can say, okay, the number of values that are free to vary as you estimate the parameters. It means these values are free and they can change and they can vary from each number to another number. In degree of freedom, df is equal to size minus 1. If you remember, we said we will talk about this. What is this 1? Minus 1 here. So minus 1 means here we are losing the freedom at least, okay, one number we are losing the freedom. Let me give you an example, then you will better understand. For example, if we have x1, then we have second variable x2, then we have x3, and the mean for them is equal to 3. The mean, the average for these three variables is equal to 3. Now here we can understand that number 1, x1, can take any number it can take. Let it be like 2. The second variable also can have any number. Let it be like 3, 4, 5, let it be 4. If it is 4, now that the third variable cannot take any number. So that is why we are losing 1 degree freedom. x3 cannot have any number here, friends. So it can take only 3. Why? Because the average of these three numbers, so if we add them, so 3 plus 4 becomes 7, 7 plus 2 becomes 9, 9 divided by 3, that gives us the value 3, because we said the mean is 3. So x1 was free, it could take any number. x2 was also free, it can take any number, but x3 cannot take any number. That is why we are reducing or subtracting, okay, 1, losing 1 degree freedom. So this is called degree of freedom. And we will look at the following 3 or types or 4 types of hypothesis, and we will conduct this test. The first test is one sample t-test, two sample t-test, then we have paired sample t-test, and we will talk about chi-square, and we will have some examples for them. Let's see here, friends. Okay, first some important libraries, and then conducting a hypothesis test. We have 5 basic steps. So what are these steps? The first step is the assumptions. We will assume something, assumptions are there. Then we have specify the hypothesis, the null hypothesis and the alternative hypothesis. The conditions, determine the sample size for the test sample, and then choose a significance label. So by default, so this will be equal to 0.05, it means 5%. It may change. So here then we have decide whether to accept or reject the null hypothesis. Now let's see and go talk about the first type of testing, which is one sample t-test. So what is this one sample t-test? So one sample t-test is actually used to compare the mean of sample. For example, this is our sample, the mean of this sample with a pre-specified value or mean value, and test for deviation from the value. So it compares two means, a predefined mean with a mean of the sample. So this is sample, it finds we have to find the mean for this sample, and also it will be given or provided as another mean, and then we will compare those two means, whether we will accept them or reject them, how much deviation is there between the two values. If the deviation is so much small, as we said here, it is compared based on this one level of significance. If it is too much small or it is less than this value, so we will accept it. If it is greater than this value, so then we will reject the hypothesis, right? Let's have an example here. The following data refers to the height of female students in an XYZ university campus which are randomly selected. So these are the height of students which are randomly selected. But here test whether the mean height is equal to 64 inches or not. At how much? At 10% level of significance. So 10% means 0.01. So this is the default value. We said it is by default this one, but it can be changed. It means we should be how much percent sure? 99% we have to say, yeah, this mean value falls between them, or this is the mean of this data set. 99% we have to be sure, and only 0.01% maybe there is some deviation that we can reject. No, this value is not the mean of this data or sample. Let's see here. Okay, the assumptions. What are the assumptions here? The assumptions for one sample t-test is samples is drawn from the population. So this is an example, but actually the sample should be drawn from the population. And then the population variance is unknown. It is also not given here. Only the mean is given. The variance is not given. And then we will list the hypothesis. The hypothesis what we have here, it is H0. It means null hypothesis. Mu is equal to mu 0, or mean is equal to, this is called mean. Mean is equal to 64, which is given here. And what is the alternative? It should be equal to, then we accept it. If it is equal to this value, then it means we are accepting the null hypothesis. If it is not equal to this value, it means we are rejecting the null hypothesis and accepting the alternative one. So here for us, where mu or mean is a pre-specified value, and it is given that it is equal to 64 inches. It is a predefined value. Now this is the list or sample size. So let me execute this and we will see, okay, the values are stored in this variable each. Now friends, standard deviation is unknown. If standard deviation is unknown, then we go in for testing and using this formula. It is called t-test for this one. As here it is already shown, standard deviation is not given, only mean is given, so we have to conduct t-test. If standard deviation is known, then we go for calculating z-test, because here standard deviation, this is called standard deviation, in A is sample size, and this is mu, which is predefined or pre-specified value, it is given. So this is the mean of whole sample. So you put it here and you calculate, you will get the result. If standard deviation is unknown, then we go and use this formula, and S can be calculated by this one, by this formula. Let's see here. So first I calculated the mean, because we need the mean, this one, the mean is required, so I calculated the mean. Then I need sample size. Sample size n is equal to ln of each, so that will find for me the sample size. And then we will go and calculate the standard deviation or standard error, which is equal to standard deviation divided by square root of sample size, if you remember in last lecture. So then we have to calculate S. So for calculating S, here I am using a for loop here, because here it is summation, means we have to go through each and every value, and from that we have to subtract the mean, and at the same time we have to square them. So each and every value, x minus mean and square of those values, and you add them all if you want to find this one, s square. So then s square is equal to square root of n divided by n minus 1, this n minus 1, into what? Summation of those things. So summation of that we have already found it here. It is stored in W. I put the W here. So S is found like this. Then we are going to print them here, the values, like we want to find the sum of all those numbers, mean and square of them. Then mean I want to print, then the number of observation I have printed, the S value, and here then we go and compare them. So this is a function T interval, a predefined function I am using. So here alpha is equal to how much? 95%. So df is equal to 9, okay, minus 1. Degree of freedom is equal to how much? It is equal to sample size minus 1, and we talked about this, why we are subtracting this 1 from it. Then log is equal to mean, so the leftmost value should start with the mean value, and this one is the standard error that we are going to find, and I'm going to print the interval here. And then after that I have to calculate the t value. So the t value, this is the formula, and you put absolute of that. We are taking mean minus mu predefined value, which is 64, and then how much it is square root of this one, and sample size divided by S. So then I have to multiply it with how much? 100. So let us see here, because I want to show it in the form of percentage, so I multiply it with 100. So sum of this x minus mean whole square, that is equal to this much, and then we have the mean, how much? It is 63 point this value. Then the number of samples, how many values we have there? Observations, 12 observations are given, 12 observations or values are given here. And then the interval, which is okay, S value, what we found is 1.9 from this formula. And then what is the interval? The interval is this one, 62.4 and 64.86, and we are observing the t value, which is equal to how much? 586. So definitely we can say that this value falls within this range, so we accept that. So the mean, it means the mean 64 which was claimed, which is the mean for this, yeah, we accept, it is valid, then the null hypothesis is accepted. We have manually calculated everything here, but instead of this we can use some predefined functions here. So the list is given, then I'm printing the list, then what, I'm taking the mean for that, then I'm printing the mean. Then here we have, okay, Ttest 1 sample mean, and I'm giving the sample here, this is the sample, the values, all the values, and pre-specified value, which is 64, and I'm going to calculate the p value, because p value is very much important for us. We are comparing with this value. How much it was said here? It is said 1%, sorry, 10%. 10% is 0. How much? 0.01. So I'm going to compare it. If this is less than this, we are rejecting the null hypothesis. If you remember, here we discussed that. Here, if p value is less than level of significance, then you reject the null hypothesis. And rejecting the null hypothesis, we will accept the alternative. So now let's calculate and run this. Yeah, so this is the list printed, this is the mean, and this is the p value. The p value is 0.05, and it is really not less than this, but it is greater than this. So what happens? We are not rejecting but accepting the null hypothesis. If it was less than this value, we were rejecting the null hypothesis, but it is not less than that, because it is 0.05, sorry, 0.5, so it is greater than that. It comes to the second part, else, and we are accepting the null hypothesis. If you are accepting, so what is the result? Then we say, yeah, the mean height is equal to how much? 64. It is valid, we accept that. The mean height for this sample is how much? 64. For the significance level of 0.01, which was given here 10%. Yeah, then we accept and we say the null hypothesis is accepted here, and we reject the alternative, and the result we say the mean height is equal to how much? 64, and it is valid. Now let's go for two sample t-test. So two sample t-test, the name itself indicates, see, two samples. It means we have two samples here. It compares the equality of means for two independent normal populations having unknown but equal variance. So as we said earlier, here also the variance is unknown but the mean should be given. So let's have an example here. A physical education teacher opines that those who practice swimming, okay, would on average be taller than those who don't swim. Among students of a college, 16 were randomly selected. Among them 6 practiced swimming and the remaining did not. So we have two samples. Sample 1, swimmers, and we have how many values here? 6 values we have, and non-swimmers we have how many? Okay, 10 values, because 10 plus how much? 10 plus 6, it becomes 16 as they claimed here. These are swimmers and these are non-swimmers, and the teacher claimed those who are swim, their height is taller than those who are not swimming. Let's see whether it is correct or not, whether we accept or we will reject the idea of the teacher. So two lists are created here, swimmer and non-swimmer. I want to print them. Okay, swimmers are printed and then non-swimmers are printed, and then we find the mean for swimmers, and then we find the mean for the average value for non-swimmers, and then again we are printing the standard deviation for swimmers, the standard deviation for non-swimmers, and then we conduct the test. So this, instead of 1, here we have it, if you remember, here we had another function, this one sample test, but here it is not one sample test. I am calling another function Ttest underscore independent, because we have two lists, we have, or two samples, we have swimmers and non-swimmers. Now we calculate the value. It returns two values, one is p value and one is the interval. So p value we require, because p value we have to compare with this significance label, which is 0.05. If it is less than this, we reject that. If it is greater than that, it means this condition is false, it goes, and we will accept the null hypothesis. Let us run and see. Yeah, so list is printed, the second list, this is the average for swimmers, this is the average for non-swimmers, and this is the standard deviations are also printed for both, and here is the p value 0.1. So it is not less than this significance level. So if it is not less than that, what will happen? We will accept the null hypothesis according to this one. If it is less, we will reject. If it is not less, if it is greater, then we will accept. So it comes and accept that. So it means the teacher claim is valid. Those who are swimming, their height will be somehow taller than those who do not swim. So the teacher claim was here. Again, another test is called peer sample t-test. So peer sample t-test, what is this test? Test for equality of means when observations are paired, means dependent on each other. Here we have independent, if you remember, this one is independent of this one. In two sample t-test, they are independent, two independent normal populations, but in paired the observations are dependent on each other. The two samples are said to be dependent when the element one sample are related to the other sample, meaningful, that is called in some meaningful manner. Let's see some example here. For example, okay, body weight before gym and after gym. Before gym and after gym, it relates to each other. We will have to check whether there is some effects or not before gym and after gym, whether the weight is increased or decreased. Okay, blood pressure before yoga and after yoga. We will check whether blood pressure is controlled or not controlled. Okay, body weight before diet and after diet. So these samples are dependent on each other. Let's have an example for them here, then you will better understand. 9 students attended coaching classes for 1 month. 9 students attended coaching classes for how much? For 1 month. The marks scored by those students in the test were recorded before coaching and after coaching. So these are the marks before coaching the students scored, and these are the marks after coaching the students scored. Now based on these marks, can we conduct that the coaching is effective in proving the marks? Let's see. 2 lists are given, 2 samples are given. So first I have converted them into a dictionary here. It is not required, but I want to display it in the form of dictionary. I want to calculate, describe like mean, maximum, minimum, all those things. You know this function returns many like attributes. So then here we are calling the function stats dot ttest underscore relation, and we are providing before coaching and after coaching, and we will calculate it returns the p-value for us. So p-value is important. We have to check it with this significance label. If it is less than, we will reject. If it is more than that, we will accept. Now let me execute and see the result. Okay, all these attributes are printed here. The count, how many observations are there in each sample, 9 in one and 9 another, standard deviation, mean 25%, 50%, and maximum of all. So then we have something called p-value. This is important, 0.05. okay, is it greater than this one? Yeah, it is greater because it is 0.051, and this one is 0.05 only. So it means it is greater, not less than this. It is not rejecting but accepting. When it is accepting, it means what? Coaching was effective. The coaching was effective. Okay friends, then the last test what we have here, it is called Chisquare. What is this Chisquare? It is a non-parametric test, means no, it is not based on some assumptions like the mean should be given or normally should be distributed something. It is not based on those assumptions of any variable used to explore qualitative data. It is used for qualitative data. In general, the test is used to measure the difference between what is observed and what is expected according to the assumed hypothesis. Chi-square test can be used, okay, in these cases. Test the goodness of fit of distribution, test of homogeneity, and test of independence of attributes. So here, now let's see an example for this. Among 460 people investigated, how many of them? 210 were literates, and among the literates 13 were smokers, where among the illiterate people 46 were smokers. Test whether smoking habits and literacy level were associated or not. So here we have to conduct a test for this, and you have to remember this one. Here we are testing the observed versus expected values. And here the hypothesis, null hypothesis, says x and y, the two values are independent or not associated. If it is null hypothesis is accepted. If it is rejected, means the values were not dependent, and they were dependent and associated. If null hypothesis is accepted, it means the value x and y values or attributes are independent and they are not associated with each other. But if it is rejected, means we go to for the alternative hypothesis, and there we say x and y attributes are dependent. Now here we have to convert it into the form of rows and columns, then we can easily understand what is there in this example. Total, how many people were there? Total we have 460 people are investigated, and among them 210 were literates. So how much we have? Okay, 460 people. So among them how many were there? 210 were literates. So 210 were literates. If 210 we subtract from this, then how many others are illiterate people? We have 250 illiterate people we have, because from this value I have to subtract this value and it is giving me this value. Very simple. In here, among these people, how many were smokers? 13 were smokers. So here we have smokers and non-smokers. So 210, how many smokers we have? 13. If we subtract this 13 from this value, it is giving me this value, non-smokers. And here, an illiterate people, here illiterates, how many were smokers? There we have 46 people. So if I put 46 people here and subtract it from this, it is giving me this value, 204. Now this is the sum of these two numbers we have total, the sum of these two numbers total here, and we have here the smokers total and non-smoker total. And this is the formula, friends, for chi-square. Observed values minus expected values and whole square divided by expected value for degree freedom is equal to 1. Okay. So observed values are given here. This is observed values. We have 13, then we have 197, and then we have 46, 200, 204, this value. And now we have to calculate these values, expected values. How to calculate those values? For calculating these values, it is very simple, friends. If I am calculating the expected value for this one, what I have to do? I have to find the sum, this sum into this sum divided by total number. So it is giving me this number, expected value for 13. If I want to find the expected value for this one, 197, so what I have to do? I have to take the sum of these two numbers and sum of these two numbers multiplied divided by total number here, and it is giving me this value. If I want to calculate this value, so I have to take this sum 250 into this sum, which is giving me 59, divided by this number, it is giving me this value. So for this one, this value, expected value for this one, the sum of this row and the sum of this column and the sum of this row, 250 into 401 divided by this number, it is giving me this value. Now we have to call the function here, stats.chi-square. This is a predefined function. So as we said, according to the definition, this is the definition. Here we have to measure the difference between what is observed and what is expected. So here we have the formula. If manually we are calculating, if you are calling the function, it will calculate and it will return the p-value for us, which is important for us, and also the range or the interval. Now I want to print the chi-square here, this value, and also the p-value, and I'm going to compare it with level of significance. If it is less than that, we will go and reject the null hypothesis. If it is greater than that, we will accept the null hypothesis. Let me execute and see the result here. Yeah, here this is the chi-square, this is the value. If you put here manually, if you're executing calculating, so it will give you 15.14 like that. p-value is equal to 0.00, so it means it is less than this. If it is less than this, what will happen? We will reject the null hypothesis. But if the null hypothesis is rejected, so what will happen? We will go and accept the alternative hypothesis. So alternative hypothesis is this one, friends. This one. X and y attributes are dependent, because we are rejecting this one and we have to accept h1. So h1 says, okay, x and y attributes are dependent and they are associated. It means there is some relationship between smokers and also literate people, non-smokers and illiterate people. So we accept reject the null hypothesis and we accept the h1, which is alternative, and h1, this is the statement, these two values are this one, the values are dependent and they are associated, and the values are printed here. The p-value is which is very much important for us, because we are comparing with this one level of significance. I hope you understood this much, friends. Different types of testing what we conducted here, and some basic definitions about p-value, degree of freedom, and null hypothesis and hypothesis testing. I hope you understood this.